Hello and welcome to Reciprocal and Quotient Identities, Part 1. And I'm going to start off by just saying, well, what is an identity? And all that an identity is, it's a relationship between trig functions that exist. So some of them, like these reciprocal identities, you already know. For example, we've already seen that the cosecant of an angle is the same thing as saying 1 over sine of that angle. And this is a relationship between these two trig functions. And we can list a whole gamut of them, like secant is equal to 1 over cos. Cotangent is equal to 1 over tangent. So we have those reciprocal identities, and then we also have these reciprocal identities, which is essentially if you flip both sides. So instead of 1 over sine, it's now sine, but that's the equivalent or equal to 1 over cosecant. Cosine is equal to 1 over secant, and tangent is equal to 1 over cotangent. Okay, so these are the reciprocal identities. What I'm now going to do is jump into the quotient identities, and these we haven't seen before, so I'm going to show you where they come from. First, I'm going to build our little grid here, and then build a little triangle here. So let's say we have a terminal arm up here, and say we have a radius. We'll just call it r for the length of that terminal arm. And then there's a point up here which will give coordinates x, y. So we know that, oh, and then there's theta down here. So we know this distance here is x, and this distance here is y. So there's our little triangle. And I'm going to show you an interesting little development here. Suppose somebody said, hey, let's take sine of theta and divide it by cosine of theta and see what we get. Yeah, I wonder what that would look like. Okay, well, what is the sine of theta? Sine is y divided by r, right? So opposite divided by hypotenuse. And the cosine is the adjacent side, x, divided by hypotenuse, which is r. So, okay. Hey, let's clean this complex fraction up. Let's multiply the top and bottom by r and see what we get. Well, the r's cancel and you have y over, and the r's cancel, y over x. Hey, looking at this, what is y over x? By golly, it is the tangent of theta. Well, guess what? That is one of our quotient identities. So these are the quotient identities. And the first one that we just saw is that tan theta is equal to sine theta divided by cos theta. That's a really useful identity. Okay, yeah, pretty nifty. Who would have thought? There's only one other of the quotient identities. Okay, and that is, what if I reciprocate this? I flip it over, I get cotangent, and that means I would flip this over. So cotangent is equal to cosine over sine. And there are the only two quotient identities. All right, now, I guess the next question is, why do we have these identities? I mean, what good are they? What do they do for us? Well, let me show you here. I'm just going to clear the screen. What we try to do, and I'm going to put an example up here. Okay, we're going to show you a little trig statement here that says cotangent of some angle x times sine of x, we believe that equals the cosine of x. Okay? And somebody comes along and says, can you prove this, please? Prove it. Okay? Well, that is where we use these identities, because what we do is a system to show that the left side and the right side are actually the same things. Now, there's a few certain key steps in doing this. Like, you can't mix and match the two sides. You have to work them separately. Okay, so usually what happens is we draw a little line down the middle here. And then we look at them and we say, well, the right side is about as simple as it gets. I think I'm just going to leave that alone, just cos x. But what can I do on the left side? Well, I can use an identity and I can switch out cotangent. Cotangent, according to a quotient identity, is exactly the same thing as cosine divided by sine. Okay, so that's exactly the same thing as cotangent. I did a little switcheroo. And then we have times sine x. Okay, so now I look at this and I go, hey, wait a minute, look, sine x and a sine x on the bottom. Why don't we cancel these? And look at what I have. I have cos x. Well, that looks like the right side. In fact, at the end of these little proofs, usually we write left side equals right side. Okay? And that is what a trig proof looks like. So there isn't that much to it. Okay? It's using the identities to swap out. Usually we try to build down to cosines and sines, and then we do a lot of canceling, and hopefully we can get the left side equal to the right side. Anyway, I'm going to stop there, and we're going to come back and do a little bit more on these trig proofs.